Hey everybody, welcome back. And if you're just joining, thanks for checking out the channel. So in this series, I'm working on building a 3D SimCity clone using HTML, CSS, and JavaScript. In the previous video, I walked through how to set up Three.js, which is a 3D library for JavaScript. If you missed that one, I'll link that in the description. You can go check that out first. In this video, we're going to be setting up an orbital camera with pan, zoom, and tilt controls. So before we dive into the camera code, there's one thing that we need to fix, and that is we do not have any Intellisense for Three.js. That's my fault. I should have read the documentation more carefully, but if you go on over to the Three.js documentation, if you're installing from a CDN or static host, which is what we're doing, I recommend using this import map and a polyfill for legacy browser support. Let's copy this, put that in the header of our HTML file. And the last thing we need to do is make sure that we pick a version for Three.js. So I'm just going to delete this and that'll pick the latest version. And then let's go into our scene.js file and replace this with 3. You can see all these methods turn green. If I highlight over these, we now have Intellisense. So that makes it a lot easier to develop with the Three.js library. Okay, so now let's get started on the camera. So the first thing that we need to do is to hook into the mouse events on the browser. So when the user presses their mouse button, they move their mouse around, we can react to those things. Let's start by adding some methods to our scene. Let's call them onMouseDown. We'll add a console log statement in here so we can see this method being called. Similarly, we need onMouseUp. And onMouseMove. And we need to expose these methods to our HTML document, so we'll add them to the export list. So in our HTML document, we need to add event listeners to our document so we can respond to those mouse events. We'll start by adding an event listener for mouse down, and then that will map to onMouseDown, the method we added to our scene. We'll just pass in false for the options here. So let's add 2 more event listeners, one for mouse up and one for mouse move. Okay, there we go. Now, if we go back to our scene in the browser, got our fun spinning cube here. So let's pull up the developer console with F12. Clear the output here. You can see as I move the mouse around in the scene, you can already see hundreds of events being triggered as my mouse is moving each frame. Similarly, I can press the mouse down. You can see the mouse down event is called, mouse up. See that as well. So all of the mouse events are working as expected. Okay, so now that we've hooked up our mouse events, we can focus on working on the camera. So we're going to be developing what's called an orbital camera. So basically our camera is going to be stuck on the surface of a sphere and it's going to be moving around that surface. In order to represent this, we need 3 parameters. So let's delete this line here. We need to define the camera radius, give it a value of 20, and camera azimuth, and camera elevation. So the azimuth is you can think of that as the compass direction, so kind of rotating around the circumference of the sphere. Then the elevation is our angle relative to the horizon. Additionally, we also need to keep track of whether the mouse button is currently pressed or not. Let's define another variable called isMouseDown. Give that initial value of false. And we need to keep track of the mouse position from the previous frame. Each frame we're going to be looking at the current mouse position compared with the mouse position in the previous frame. We compute the difference between those coordinates, and then we use that to adjust the azimuth and the elevation. So we'll define previous mouse x equals 0 and previous mouse y equals 0. Okay, so those are the parameters that we will need to fully describe our camera. So let's go back down to our mouse events. So in the mouse down, I need to set is mouse down equal to true. And then of course on mouse up, we need to set this back to false. And in our mouse move event, we only want to move the camera if the mouse is down. So one thing I forgot to do before is to pass in the mouse event arguments into our methods here. So I'm not actually using those events and mouse down and on mouse up, so I'll just leave that out. But for on mouse move, we need this event data so we can get the mouse position. So in this block of code here, we need to update our azimuth and elevation of our camera when the mouse moves. So we'll first update the azimuth. We need to get the mouse position from the current frame, and then we need to subtract off the X position of the mouse from the last frame. And then for the camera elevation, take a similar approach. This one does not have a negative. We take the current Y position minus the previous Y position. So another thing that we need to do is we need to lock the elevation so that the camera doesn't go below the horizon. It just doesn't really make sense in this type of game. So we'll add an additional statement here. So we take the minimum of 180, the maximum. So what this does is basically clamp our camera elevation between 0 and 180 degrees. Finally, we need to update our camera position. So we have not written this method yet, but we will do that shortly. And then, of course, we need to update our previous mouse position so that we can use it in the next frame. Okay, there we go. So let's go ahead and write the code to update the camera position. So this code involves a fair bit of trigonometry. If you're interested in this, I would highly suggest looking up spherical coordinates and how to represent those in a Cartesian coordinate system. I'm not going to get into that math right now. I don't think that's really the point of these videos. So I'm just going to copy and paste this code in. So there's a bit going on here. You can see that this math involves sine and cosine functions, but you can see it's dependent on our camera radius, our camera azimuth, and our camera elevation. Finally, I'm forcing the camera to look at the origin, just so the camera stays focused looking at that point. And then finally, we call this update matrix method to apply these changes to our camera. So I just noticed I made a small typo here, so let's fix that quickly. Okay, so let's go and look at our browser. And it looks like we can't see anything, but if I click my mouse down, then it does appear. I think the issue here is we're not setting the initial position of the camera like we were before. The camera is just at the origin. So in our camera setup code, we just need to call update camera position right here, and this will set the initial state for the camera. We go back to our renderer, reload the page. You can see that's now working as expected. So the camera is a bit too far away for my liking. I can't really see what's going on in this rotating cube. It's kind of confusing with the camera moving as well. So let's fix those two things. Let's go and change the camera radius to 4. And then let's comment out these two lines right here. We'll save that. Go back to our browser. Now if I hold my left mouse button down and drag the mouse, you can see the cube is rotating. Go up and down. You can see that our clamping is working. We can't go below the horizon. I'll rotate above the cube. Great, so all of that is working as expected. Okay, so going back to the code now. I think before we get any further, I would like to refactor some of this code. I want to move the camera code into its own file so our scene code doesn't get too messy. Let's go ahead and create a new file under source, call it camera.js. All right, so the first thing we need to do is to create a new function, which we'll export. I'll create camera. And the camera does depend on the game window to know how big to make the field of view. So we need to pass that in as an argument. And then we're going to need to return our new camera object. Going back to the scene, make sure we grab this import statement here. And let's take our camera setup code and let's just cut that and paste that into the top of our function here. Now we also need our mouse event handlers. We're going to copy those and paste those into our camera class. And I'm going to use the words class and function interchangeably. I'm kind of used to the world of classes in my day job. Really, classes and functions are basically interchangeable in JavaScript. We'll update these methods later, but for now, let's go and just grab our update camera position code, cut that, and paste that into the bottom camera function here. We want to return the on mouse down, on mouse up, and on mouse move methods. We can access these in our scene class. So let's create our camera up here. And if I hit enter here, VS Code will automatically import. We do need to add a .js extension, otherwise that won't work. And remember to pass in the game window as an argument to our create camera method. Okay, so now we need to go and update these mouse events to point to our camera instead, since this code is now on our camera. So we can just call camera on mouse down here. Let's delete the console log statements. Camera on mouse up, and then camera on mouse move. And pass in the mouse move event arguments. The last thing we need to do is export the actual Three.js camera object here and return that as well. And then in our scene, when we call our render method, we actually want to pass in the Three.js camera, not our camera object. So the naming's a little confusing. It can be camera.camera, but I think that'll work for now. And let's delete these two lines here. So going back to our browser, you can see that everything is still working as expected. And now our scene class is much cleaner. So let's finish out this video by implementing pan and zoom for our camera. So I want to be able to use the right mouse button to zoom in and out of the scene and use the middle mouse button to pan around the scene. So I need to keep track of not just the mouse being down, but is it the left mouse button, the right, or the middle? I'm going to change this to is left mouse down, and then add two more variables for the right mouse button and the middle mouse button. I'm also going to define some constants that correspond to the button in the event data. You'll see what these are used for in a moment. In our mouse down and mouse up events, we actually need to get the event data from the mouse event to know which button is pressed. So if I go back to my scene, I am now going to pass that event data into my camera on mouse down and on mouse up events. And likewise, I'll add the argument here. So now I need to check which mouse button was pressed and set the appropriate variable. So I can check my event data, event.button. It's equal to left mouse button, which is a 0. Then I want to set is left mouse down equal to true. Likewise, if You press the middle mouse button. You just set is middle mouse down equal to true. And I'll do the same for the right mouse button. Okay. Now we need to do the same thing in our mouse up event. Delete that, paste that in, and just need to set these to false. Now in our mouse move event, we need to handle the appropriate mouse button being down. So our code that previously controlled the rotation of the camera, we want that to be when the left mouse button is down. We also need to handle is the middle mouse down and is the right mouse down. So this handles the rotation of the camera. The middle mouse button handles the panning of the camera. And the right mouse button handles the zoom of the camera. So let's start with the zoom because that's the easier one of the two. I need to update my camera radius, so the distance my camera is from the origin when the user is holding the right mouse button down and moving it up and down. So I want to define some more constants here. My minimum camera radius set to 2, and my max camera radius set that equal to 10. Now back in our on mouse move event handler, so in this if block here, I want to update our camera radius. So I'm going to change the camera radius based on the change in the mouse Y position. Don't need that extra set of parentheses. And I've actually already tweaked this before, and I know I need a constant of 0.02 here. This controls the sensitivity of the zoom. And then we also need to clamp our camera radius between our min and our max values. So the clamp between the max camera radius and the min camera radius. That's using the same approach that we used for the camera elevation. Then of course we need to update our camera position. Now I noticed that we're reusing this change in Y position here. So I'm going to define some new constants called delta X. That will be our change in mouse X position. And delta Y, which is the change in mouse Y position from frame to frame. Use delta X here, delta Y here, and likewise down here. Okay, so let's go back to the browser and make sure that our camera zoom controls are working correctly. If I hold the right mouse button down, move the mouse down, that zooms out. If I move the mouse up, that zooms in. If I rotate around, you can see that the zoom is working correctly. It's properly clamping at the minimum and maximum limits. So great, that works exactly like we want it to. So next we need to implement the panning for our camera. So how that's going to work is when I'm holding the middle mouse button down, if I move my mouse left and right, that will pan the scene either to the left or to the right. And if I move my mouse up and down, that will pan the scene forward and backward. Going back to the code, I need to define two different vectors, and these are the forward direction I'll be traveling along and the left direction. I'm going to define a new vector called forward. And for this, I need to get the forward direction of the camera. So I can take this by taking a z unit vector that just has a 1 in the z component, and I can rotate that. So I'm going to rotate that around the vertical axis of the scene, which is the y-axis. So I'm going to define my y-axis as a constant. And this will just be a 1 in the y component. Going back down here, I'm going to rotate that z-axis vector about the y-axis by the camera azimuth. And I need to convert this from degrees to radians. So this will rotate the z-axis vector to point in the same direction that our camera is facing. And likewise, we need to do this for the left vector. So this is going to be rotating an x-axis vector instead of the z-axis vector. I'm rotating that by the same amount about the y-axis. And I just now noticed an issue with this code down here. This is not right. This should be divided by 180. So I guess that's what I get for copying code from the internet. And I think what I'm going to do is I'm going to define a constant up here. Degree to rad. I don't make that same mistake again. And I'm going to replace all instances of this. I can do Command-Shift-L on Mac. Update everything at once. Update these. There we go. Got that fixed. So now that we have our forward and left vectors defined, we need to go ahead and update the camera origin using these. How that will work is I will move the camera origin in the forward direction depending on the value of delta y, and I need to move the camera in the left direction depending on the value of delta x. So first we need to define a camera origin variable. Add one more variable up here, and this will be a vector 3. Just use the default constructor because that's just going to be a 0 vector. Going back down to our middle mouse down code. So I need to move my camera origin in the forward direction. And the amount I move it in the forward direction is going to be this scalar value multiplied by our delta y. And let's do the same for the left direction. That is going to be controlled by the delta x. So if delta y is larger, we're going to move in the forward direction by a larger amount. And this negative 0.01, it's a value I've determined by experimentation. This basically controls the sensitivity of the panning controls. And lastly, we need to update the camera position to apply the camera origin updates. And we need to update our camera position method to include our camera origin offset. So after we've set the position using the spherical coordinates here, we can just add on our camera origin. Okay, and we also need to update the look at so that the camera is always looking at the origin. So let's go back to the browser. Looks like we have an error. Can't access lexical declaration, degree to rad. Okay, let's go back and see where that's defined. Looks like when I updated everything at once, it also included that. Replace that with pi over 180. Going back, okay, everything's working again. So I can rotate my cube, I can zoom in and out. Now if we try our panning controls, smooth as butter. Can move the camera origin over here, so now the cube should rotate around that. It's a bit disorienting because there's only one cube in the scene. But I can shift the cube back to near the origin of the camera, and we should be able to rotate the cube in a much tighter circle. So great. We have our rotation controls, we have our zoom controls, and we have our panning controls. So our orbital camera is complete. So going back to the code, just a bit of cleanup I wanted to do. A lot of constants, parameters, I call them magic numbers. I don't really like these lingering in the code. I like to have them defined in one place. So let's go up here by our min and max camera radius. Let's define our rotation sensitivity. I believe that was 0.5. Zoom sensitivity, just 0.02. And our pan sensitivity is negative 0.01. I'm going to go replace these numbers with those constants. And finally, the zoom sensitivity. And we also need to move our min and max camera elevation constants as well. So min camera elevation, let's do about 30 degrees. For the max camera elevation, I actually want to make this 90 degrees. I'm not sure why I had it set to 180 before, but we really only want the camera to go between 30 degrees and the vertical. If we set it to anything over 90, that will allow the camera to go over vertical, which is not what we want. So get the min there, and the max right here. Great, so that makes our code a lot more readable. You can see what all these multipliers are. And when we need to go and tweak our camera later on, all the parameters are defined in one location. So that's about it for this video. All I really wanted to do was get the orbital camera working, and we've done just that. Out of our rotation, our zoom, and our pan. So in the next video, we're going to work on actually creating our world. So creating a 2D array of tiles, which you can populate with buildings and roads and grass and things like that. Thanks for checking out the video. Thank you for supporting the channel. Please like and subscribe if you like this tutorial and want to see more. And until next time, take care.